Welcome to the session on demand paging. We assume that you have understood the prerequisite topics, namely services offered by operating system and simple paging. This will help you in better understanding of this topic. In this session, we will discuss about demand paging concept, page fault and page replacement. Let us consider a scenario to understand the concept of demand paging. There are two jobs, namely job A and job B, with 2 and 3 pages respectively as shown. Assume that the main memory contains 4 frames. When user wants to execute the job, as discussed in simple paging, we need to load all pages of the concerned job into main memory for execution. Hence, to execute these jobs, let us first load pages of job A. Consider job A's first page, page 0, occupies frame 0 in main memory, and page 1 occupies frame 1. Now, let us try to load job B. Can we load all the pages of job B into memory? No, because at this point we have only 2 memory frames free. This is the limitation of simple paging, where we have to load the entire job, that is, all pages of the concerned job into the memory. So, how can we solve this problem? We can load the pages based on the need. This is called demand paging. Let us now understand the concept of demand paging. We know that all the pages of a job need not be allocated to memory at a time. Processor works with a particular page of a job at a time. So, a page is brought into the main memory only when there is a demand for that page. Although sufficient memory may not be available for all the pages of job to fit into main memory, only the demanded pages are brought into the memory, thus providing the user an illusion of infinite memory available. This concept is also referred to as virtual memory. As we know that in demand paging, a page is brought into main memory only if it is requested. This may lead to page fault or page replacement when the page requested is not found in the memory. Let us understand the page fault first. We have two jobs, job A and job B, having 2 and 3 pages respectively. Assume that main memory of the system contains 4 frames. We know that if a job has to be executed, it has to be loaded into the memory. Let us assume a request for page 2 of job B arrives. Is the requested page 2 of job B already available in the main memory? No. This is known as page fault. Page fault is said to occur when a user demands for a page and the page is not at all available in the main memory. Now, let us look at the concept of page replacement. Here we have two jobs, job A and job B, and the main memory is currently full as shown. Assume a request for page 0 of job B arrives. Can we load page 0 of job B into the memory? No. Why? Because the main memory is full. So, how can we solve this problem? We can solve this problem by replacing a page which is already in the main memory with the newly requested page. Here in this scenario, page 1 of job B, which is already in the main memory, is replaced with user requested page 0 of job B. The processor will decide which page needs to be replaced depending on page replacement algorithms. This is known as page replacement. Let us summarize demand paging. In demand paging, a page is brought into the memory only when there is a demand for that particular page. If the requested page is not available in the memory, then it is known as page fault. If all the memory frames are occupied, then identifying and replacing a page that has to be replaced for the newly requested page is known as page replacement. For assignments, refer exercises under the memory management topic in lab guide.